Hello and welcome to this talk on continuous delivery with Azure Web Apps. My name is Vidar Kongsli. I work at Brevid based in Oslo, Norway. We're going to investigate a lot of the functionality that we have available to us in Azure Web Apps for deployment of software, deployment of our application. And that is a very important part of continuous delivery. So we're going to focus on that. But before we get into the technical details, I would like to point out a couple of things regarding the heritage of continuous delivery. To me, this book, Lean Software Development, has a lot of foundation for continuous delivery. It's a very good book from Mary and Tom Popendick. It was released in 2003, I think. And it has a lot of good information that we can look at. But there are two basic points that I would like to emphasize. First, the notion of delivering software as fast as possible. And the other one is build integrity into our process. These two are, to my mind, one of the main topics that we need to keep in mind for continuous delivery. Another book that I would like to point to is the Continuous Delivery book by Jess Humble and Dave Farley, which was released, I think it was in 2010. They give us principles for software delivery that we are going to have a look at. So first, they say that you should create a repeatable, reliable process for releasing your software. You should automate almost everything. You should keep everything in version control. If it hurts, do it more frequently and bring the pain forward. Again, build integrity in. Done means released. We are considering ourselves with everything until our application is in production. And everybody is responsible for the delivery process, meaning that the entire process should be available to all people in the team. And of course, you should do continuous improvement of your deployment system. So, when I started my career as a Lotus Notes development in the late 90s, we had a system where you could deploy your application in a quick, reliable, and repeatable manner. It was all built into the system, and you can create your process around it. Moving ahead 20 years, we have Azure. We have a smørgåsbord, a buffet of different options to choose from. And the problem becomes what to choose. How do we set up our continuous delivery system? And my suggestion is that we should go back to the theory in order to guide us on what to choose, because there are so many options it can be overwhelming. So, what options have we for deploying our software to Azure Web Apps? The first option you are probably familiar with, deploying directly from Visual Studio. It's easily available to everyone. Or you could create your entire build system infrastructure using build servers, for instance, in Azure DevOps pipelines, or all other third-party solutions such as TeamCity, Octopus Deploy, Jenkins, and so on. But there are more options. One option, which I call version control deployment, is something that we will look into. And also, I will have a look at how we can use the Docker tool and the Docker tool chain to do our deployments using containers. So let's start with Visual Studio deployment. This is typically a build and deployment pipeline for that option. In your local development environment, you code your application, you compile it, you might run some tests, you build the package, and you publish it directly to the web app, to the Azure Web App. in the scenario of a build infrastructure, you still have your development, your coding, and you check in your code to the local repository, and then you push it to some Git repository remote. Then on Azure DevOps pipelines, you check it out, it is compiled, you run the tests, you build your packages, and you publish it to a web application. So for the third option, version control deployment, you still do your coding and you check it in to your local Git on your local environment, but then you push it directly to the web app and you have it checked out, you have it built, running tests, build the package, publish it, and run it on the Azure Web Apps infrastructure. So in this case, we don't need any external infrastructure set up for our build and deployment pipeline. So to do this, we use a system called Kudu. It is not this Kudu, but this one. In the Azure Web Portal, you find it under the Advanced Tools. There's also a separate portal that is automatically provisioned that you can where you can access it. And there are a couple of things there that in this tool that I would like to point out. First, on the left, we have a few endpoints that we can use to connect to it using a computer. There is a Git service, there is MS Deploy, there is an FTP service where you can push your application, and there is a custom REST-based API. Also, for the developer, here having a silly glasses, you have this SCM portal, the site configuration portal, or site control management portal, I should say. And of course, you have your normal web front end where your user can access your application. Here, your users have a top hat on for some reason. So, what we can do then is that we can, on our local system, do our coding, check it into Git, and then push it directly to the infrastructure and have it built there. So going back to this slide, there are two areas or two paths on the local file system that I would like to point out. One is the repository. Here is where your source code is pushed. And there is the www root folder where IIS will serve your application. So the source code is built and then pushed to the www root in order to deploy the application. So let's have a demonstration. So here I have a very simple .NET application. It could be other languages, but I choose .NET. So this is just a demo application, .NET Run. This is, as you might see from the naming, Jokes as a Service, or JAS, as I would like to call it. So let's try and issue some requests to it. So here we have just a simple root endpoint where I get some metadata about the other endpoints. I could go to /jokes or /science jokes or Chuck Norris for Chuck Norris jokes. And also there's a health endpoint. So let's have a joke. Okay. I can issue a new request and I get a different joke each time. So this is my important application. I would also like to point out the health endpoint. It is healthy. So what I can do here, I have also provisioned a web application called NDC Oslo 2020 Jokes 1. In Azure, it is empty for the time being, so let's try to push the application to it. So the first thing I need to do is try to enable Git push to it. Azure Web App deployment source config local git. I need the name of the application, NDC Oslo 2020. Jokes 1, and the resource group is NDC Oslo 2020 RG. So what I will get back here is the Git endpoint that I can push to. But I need to have some kind of credentials in order to push to it. Azure deployment. Oh, sorry. Azure Web App deployment list publishing profiles. So now I get a JSON array with some usernames and passwords that I can use when I push to this. So here is a username and a password. I will use this to construct the URL. And all the security people look away. This is not how I would like to do it in production, but for the demo purposes, I have a short script here that will construct the URL for it. And then I will register it as a remote for Git. So here I take the URL, Git remote, add jokes, Git push you jokes. So here you might see that it will actually generate a deployment script and run a build and deploy for my application. So it kicks off .NET Publish, basically. Once that has been done, it will be copied to the www root folder, as I talked about earlier. Let's see when it finishes up. It is copying the file, and if we move back here, we shall see that my application is now deployed. Let's have a science joke this time. Okay, good. So the next step that we can do now, instead of having it automatically generating a build script, we can try and create our own script. So let's create a PowerShell script. Sorry, not there. Deploy PS1. No, sorry. So here I basically have a deployment script that is similar to the one that is actually running or being generated automatically. It basically does .NET Publish, and then it uses a tool called Kudu Sync to synchronize the compiled files to www root. So, but what we can do now is we can add some more steps to our build. So for instance, let's run our tests. So .NET test, I need a parameter for that, where I tell it where the test project is. So, and I can try and test my script here locally. Deploy, sorry. Just tell it where to place the files. It will now basically run the tests and then publish the application. Oh, let's see, what did I do? Oh, should probably run the test before, and I should not run this synchronization command because this tool is not available, so I have a separate switch for that. No sync. So now I've added one of the quality assurance steps to my build pipeline, which is running the tests. And before we do anything else, there is also another functionality that I would like to point out that's available to us in Azure Web Apps, and that's something called run from package. Instead of having the application files copied one by one into www root, we are creating a zip archive of our entire application, and then we have the infrastructure mount that into a virtual directory on the file system, which is a more reliable and a quicker way to deploy our application. So if I add a couple of more steps after the publish application, I create a zip file from it, and then I create a separate file called package name txt, which tells the infrastructure which zip file to deploy. So let's try to run that locally first. Deploy temp build tmp and deployment directory publish. So what we have then, oh, what was that all about? Let's see here. I didn't save my file. So in the publish directory, we have one zip file, which is our application, and this package name txt, which only contains the file name of the file to deploy. So before we push this to web apps, we need to tell it to use this deployment method. So Azure Web App config app settings, set settings, a lot of settings. There's a special environment variable that we need to use. Web site run from package, and we set that to 1. Okay, then we can add and check it in. So let's try to push it. So this time, project type run from zip. So what did I do? What did I do wrong here? Project type run from zip. Let's go and have a look at the portal. So here's our run from package. Should be okay. So it said, what does it say? Preparing deployment, skipping build, project type run from zip. So yeah, of course, there is one thing missing. We didn't tell the web apps infrastructure about our deploy.ps1 file. Good, so that's very important, so let's do that. What we need to do then is create a special file called deployment. And this one should just have one entry, which is the command to run the build from. And here we are saying that it should run PowerShell and execute PowerShell and run this file here. So let's check that in. Let's push some jokes. All right, so let's see. Aha. So now it says running a custom build command. So now it has started to execute our file. So there are a number of ways we can do this. The first thing it will do, it will look for an environment variable on the infrastructure called deployment. If it doesn't find that, it will look inside the repository root for a .deployment file. And if it doesn't find any of those, it will try to figure out how to build the application, basically. So that was the first approach that we had. So, good. If we now go back here, we can have a look at this Kudu services portal that I talked about, or the SCM. So let's have a look at the file system. First, we can go into the /data/site packages, and here is our built zip file with our application, and the package name txt references which zip file should be mounted. So if we go to the site root, and if we try to edit one of the files here, we will get an error message saying that this is not allowed. So as a consequence of this approach, the web root is read-only, so nothing can write to it because it's just virtually mounted from the zip file. So another step that we can do, or that we can add to our system or deployment system, is to use deployment slots. Deployment slots are virtual sites that you can use to push your applications before putting them into production. So we have basically the same Git possibilities available to us like we have on the main site. So if I run Azure Web App deployment source, if I can spell, config local git, and in this instance I give it the name of a deployment slot that I have already provisioned. Slot pre. I call it pre because it's kind of pre-production. And as you can see now, it has a similar jokes Git endpoint that we can push to. And likewise, we have the same publishing profiles with the same, or rather other usernames and passwords. So I can create a remote for the pre deployment slot. So we can register that as another remote repository in Git. Git remote add pre. And we can also push to that. So basically what we can do now is that we can push the application, have it built on the deployment slot, and then we can, if we want, test that it works. The infrastructure will actually test that the application starts, and then we can switch it automatically into production to avoid downtime. So while this one is building, let's go back to the slides, I think. So to summarize what we have seen so far, we are pushing directly to the infrastructure. We have created a locally runnable build script, which means that we can debug it and run it locally and see that it works. We have added automated testing to our pipeline. We use the run from package feature, which allows to have a more reliable and quicker deployment. And this is approach good for early deployment and for a small team, maybe 1 or 2 developers. So you can extend this, of course, by using a remote repository like GitHub or Azure DevOps repositories. So in that case, you will develop locally on your system. You will push it to GitHub, for instance. Then you might add quality assurance steps like pull requests and pull request reviews. And then you can have GitHub trigger the web application to pull the latest and build it on the build system. So in this way, you can add on branching strategies. You can do different quality assurance like peer reviews, stuff like that. And you can also deploy to different environments, for instance, for different branches in the version control system. So this is also a fairly good solution for small teams, which again does not need an external infrastructure for building or build and deployment. So there are some possible enhancements that you can do. I just showed you the basic steps. For instance, you can have your build system of preference, cake, sake, whatever. You can add your automated site verification steps to it. And of course, you can push to Slack or Teams whenever a deployment has been done. But of course, some of the shortcomings here is that this is not very visible. The history of the deployments to a certain web application it's available, but it's not really easily available. And having reports is somewhat difficult. So let's have a look at the second option, using DevOps pipelines. So just to finish this last demo first, we have now deployed to our deployment slot. We can then swap between production and the pre-production deployment slot. Azure Web App deployment slot swap, slot pre, and here I have to give it the name of the web application, Oslo 2020 jokes 1, and the resource group. So now it will first check that the application is running in the deployment slot. If it is running, then it will shut it down and it will apply the production properties to the pre-deployment slot, and then it will fire up the application. And again, it will check that it runs, and then it will switch traffic to it. Once the traffic has been switched, the old slot will then be have the pre-configuration applied, and then it will be spun up again. So it's kind of, it takes a few seconds to perform the application. But okay, let's have our next demo, Azure Pipelines. So let's see here. Let's create a YAML file with the pipeline. Oh. So here I have scaffolded a basic pipeline. There's a trigger which says that it should automatically trigger when you deploy to the NDC Oslo 2020 branch. It will run on Ubuntu. My first step is just to have the build number written to a version txt file so that the application can serve its version number. Then we run the unit tests, basically a .NET CLI test command. Then we publish the test results to the DevOps portal so that we can go through it. Then we publish the application. We zip it like we did on in our build system, and then we publish it to the artifact repository. So, but first, let's try and improve this. Let's first let's try to reuse the script that we already have. So the steps to publish and the steps to run the unit tests. Let's instead run the script that we have, sorry. Pipes. So instead we are running PowerShell deploy.ps1. And also let's add on the deployment part directly. So instead of publishing to the artifact repository, let's just push it directly to Azure. So here we can do a web app deploy. We give it the Azure subscription, the application type, the application name. We use the deployment method read from package like before. And now actually let's, in the interest of time, let's go straight ahead and deploy to a deployment slot instead. Pipes. So here what we added, deployment to the slot name pre, and then we issue a command to switch it into production afterwards. So yes, we have a new file. Git add git. So in this time, let's push it to the origin, which is on. Oh, sorry. Origin. Need to use the correct branch. So let's head over to the Azure DevOps portal. Let's create a pipeline. My code is on GitHub. It's this one over here. I'll use an existing pipelines file. Let's have a look on the NDC Oslo 2020 branch. And there it is. And I just go ahead and kick it off. Takes a few seconds to provision the build server. So now it's checking out the code. It's set the version number, and now it's running our custom build script. Good. So while we wait, let's see. Okay, it's running the tests. We publish the test results. So it picked up our test results. It's deploying to Azure. It's setting this website run from package to 1 before it pushes the package. And now it's finished deploying to the pre-deployment slot, so now it's doing the swap. So the slots are warmed up. Now it will try to reapply the configuration and start up the application again before doing the switch. So this might take a few seconds. So while we wait, let's just have a summary what we have done so far. So now we have offloaded the build and deployment to our dedicated environment. We can have our build policies set up we can have more advanced pipelines. There are a lot of tasks available on Azure DevOps out of the box, and also through the marketplace that we can add on to our pipeline. But again, there are more moving parts that we need to take care of and need to maintain. And we kind of lose the possibility to test our pipeline locally. Only the reusable test script that we created is really something that we can test locally. So that means that our feedback cycle is quite much longer. When we do a change, we watch the result. It takes a few minutes typically. So let's see how we are doing. So now here, the swap seems to be finished. So if I move to my second jokes server, we should get some jokes there as well. Good. Excellent. So the next demo that we can have, or change that we can do, is to use the Docker toolchain to build our application and also to deploy our application. So that means that the compile, run test, build package part is inside a Docker file. We will publish the resulting container image to the Docker hub, or rather, I have set up an Azure container registry for this purpose, and then it is pulled from there to the web application. So let's have a look at that as well. So first, let's create a Docker file. So here we have a multi-stage Docker build. So we use two images for this. One is called Slim, or 3.1 Buster Slim, ASP.NET 3.1 Buster Slim, which is only the runtime environment. And one called just Buster, which contains the SDK that we can use to build the application. So the first step is the build step, where we actually restore, we run the .NET tests, and we publish the test results. So here I've done some command line tricks in order to get the test results out. So here, if the .NET tests failed, meaning that it will any tests failed, it will actually create a test failure file. And this file we will pick up in the publish part and stop the publish if there is a test failure. So here, in the publish step, we test, is there a test failure file? Then we just exit with a non-zero error code. Otherwise, we will publish the web application. And basically, we create the final distribution image by copying only the compiled files to it. I would also like to add on a health check, which basically checks that -health is available, so that the application, we can detect early if the application doesn't boot. So Docker build, let's tag it with jokes latest. Here I have already the base image is pulled, so it's quite quick. The restoring of the for the .NET application, however, takes some time often. Now it's running the tests. Good. Let's try and test the container or the image. Let's see, Docker run, access it to port 80, attach jokes latest. So let's see if we can issue a few commands. Okay, so it seems to be up and running. Let's have a science joke this time. Good. So now we have our Docker build pipeline set up. The next thing we need to do is to create a separate Azure pipeline for it. Azure pipelines.docker.yaml. So again, let's have a quick walkthrough. We have a trigger like before. We run on Ubuntu. We create a version txt with the build number. Then we kick off the Docker build, basically the same command like I just tested locally. And then we have a separate step to fire up a container from the image which is labeled test equals true. And here we copy the test run results. And then we remove the container before going on to publishing these test results to the Azure DevOps. So this is kind of a way to extract the test results from the image. So the next thing, we log into the Azure Container Registry. We push the container image there, and then we tell the web application that it should run this container, or should use this image to and create a container from it. So here we use the Azure CLI to set Docker custom image name. And again, we do this on a deployment slot, and then we swap it into production. And this time I used Azure CLI also to do the swap operation. So again, let's check this in. Let's see, do we have everything? We have a new Docker file, and we have the Azure pipelines for Docker. Oh, let's do one more thing. Let's just go, and we don't need the old pipeline to trigger anymore. So let's just change. Let's change this. So it is pushed, then we move over to the pipelines, Azure DevOps pipelines, and we create a new pipeline. So, sorry, new pipeline, again, GitHub, existing pipelines file. Let's look at the NDC Oslo 2020 branch. This time, let's have the Docker one and kick off a build. Okay, so now it's kicked off the Docker build. It has pulled the images. It's starting running the script. Okay, so it's running the tests. Tests are good. And publish the application, or sorry, publish the image to the repository, push the image. And we tell the web application which container or which image it should use. So, of course, here in this case, I have a provisioned a web application which runs on a Linux application plan. That's basically it. It also has set a few configuration parameters. Because I'm not using the Docker hub, but rather I use Azure Container Registry, I need to have the URL to the server and a username and password that the application can use to connect to it. Yeah. So let's see, how are we doing? So it has deployed the container. It's now doing the swap. So let's see if we can issue a command or issue a request to it. So the host is, this is jokes number 5. Let's see. Oh yeah, there it is ready. Serving jokes. Let's have a Chuck Norris joke. Good, there we go, there we go. So also I would like to point out that we now here in the portal can go and look at our test results. Basically we have everything available to us here also. In the case where any tests fail, we can go here into the portal and see which tests failed and so on. Good, so just a summary. To summarize, we have now used the Docker toolchain, which might be your preference. You can easily develop, you can run and debug everything locally, and everything like the runtime in tools included in the container image, so that you are basically free to pretty much include anything that can run on Linux and can talk HTTP to run your service. You get a somewhat cheaper hosting if you move to Linux versus Windows, and further down the line, if you want to change hosting provider, you have an image technology that can run on all large providers. So, just to have a brief talk about the key features of the Azure Web Apps that do a web application service that we have talked about. We have seen how we can run our build on the Azure App Service itself. We have seen how we can use deployment slots to deploy with zero downtime. You can also do an automatic swap on Windows infrastructure if we want to, because in my examples I explicitly issued a swap command, but you can have the infrastructure set up to do that automatically once a deployment is done in a certain slot and it detects that the application is healthy, it can swap automatically into production. We have also looked at the opportunity to run containers on Azure Web Apps. I didn't say much about that in the beginning, but I have provisioned all the infrastructure using ARM templates. I would urge you to do either that using ARM templates or the Azure CLI, any form of scripting instead of manual provisioning is good. So again, we started out to look at the different options that we have for deployment to Azure Web Apps. And I said that we try to use the principles of continuous delivery to guide us on how to choose how to do it. My message would be that you should choose the deployment approach based on your current needs, and also be open to switch approach during the lifetime of your application. But have your build and deployment scripts checked into VCS. Have it in the proximity with your code so that it is available to developers in an easy manner. And also you can reuse it if you switch your deployment approach. So here are just a small summary. Pushing from local Git is a good way to get started. Maybe for small scale development, single developer, maybe 2 or so. As a proof of concept, doing prototyping, it's a good approach. You can add on to do the deployment via GitHub, for instance, or services like that. For small teams, you can have multiple environments. You can do branching, creating your logic and your process around that, pull requests and so on. The Azure DevOps pipelines is of course a more full-blown dedicated infrastructure good for complex solutions, more advanced workflows, versioning, reporting, and so on. And also as a variant of that, you can combine that with the Docker tool chain, where you are kind of more cloud independent. You can also have versioning, reporting, and so on. So it's more of a what you prefer in terms of your CI/CD. So that's it. My final message would be to travel light. Do not carry more than you need. Don't have too much luggage. Rather, just pack whatever you need. So with that, I would like to thank you very much for attending. I will be available on Slack if you have any questions. So let's have a look. Okay, no questions there now. But again, thank you very much. I'll be happy to answer any questions if you have any.